All right, this lesson is on diagonals in 3 dimensions. We focused on Pythagorean theorem with 2D diagonals, which is just like a flat surface. So just like across the top of something, like across the top of a computer screen or a television screen, anything flat. Today we're looking at diagonals that are 3-dimensional. There is a formula that we're going to use. It is not specifically Pythagorean theorem. There's something similar that is for diagonals with 3 dimensions. Okay, it is d squared. Okay, so that's the diagonal squared. It's going to equal the width squared plus the L squared, or the length squared, and then plus h squared, or the height. Okay, that's that formula. D squared equals width squared plus length squared plus height squared. All right, and let's turn in. Okay, on examples 1 and 2 here, we're going to find the diagonal. Okay, we're given the dimensions. We have this length across the box, that's our L, is 6. We have the width of our box, which is W, and we have a height of this box, which is 10. I'm looking from this back corner all the way across the figure through it to the very front corner is the diagonal I'm looking for. It's like a cross section of the box. All right, so our formula again, d squared equals length squared plus width squared plus height squared. It doesn't matter the order that you put your squareds. Okay, and let's fill out. We're looking for the diagonal. So the diagonal squared is going to equal, well, the length we said is 6, so 6 squared, plus the width, which is 4, so plus 4 squared, and the height is 10, so plus 10 squared. And then square all of those, so 36 plus 16 plus 100. So d squared equals 152. And then similar to Pythagorean theorem, on my final step, I have to square root d. D has to be by itself. So the diagonal, one of the diagonals then, is the square root of 152, which is 12.32. So to the nearest tenth, our diagonal is 12.3 inches. Okay, example 2. It doesn't show you all of the dimensions of this box, but we do know that this is a 3-dimensional figure. Okay. Now, go ahead and label your dimensions. Okay, I know this is my length, this is my width, and that's my height. Our formula, write that out again. And fill in what you know. I'm still looking for that diagonal. So d squared equals my length squared, which is 10 squared, plus the 6 squared is my width, and the 15 squared is my height. So 100 plus 36 plus 225 will equal d squared. Add them together, 361. But that is not my diagonal. That is just that is both of my 2 diagonals, like diagonal times diagonal. So square root it. D equals, let's see, 19, even. Okay. Good. All right, and now flip onto the inside. We're going to look at some word problems. A rectangular box has a length of 6 feet. Okay, so we have a length of 6 feet and a width of 2 feet. The length of the 3-dimensional diagonal, that's important, that's the diagonal, is 7 feet. What is the height? I'm looking for the height of the box. I'm not looking for that diagonal now. Let's list out what you know. The length of the box is 6 feet. The width of the box is 2 feet. And the diagonal, or the D, is 7 feet. What is the height? Height equals, I don't know. So again, your formula, D squared, length squared, plus width squared, plus height squared, or in any of the order. Fill in what you know. I know that my diagonal is 7, so 7 squared will equal, my length is 6, so 6 squared, plus the width is 2 squared, plus, I don't know that height. I'm just going to leave it h squared. That's what I'm looking for. Okay, let's square the rest of these. So 49 equals 36 plus 4 plus h squared. 49 equals 40 plus h squared. I'm looking to solve for h by itself. To get h by itself, I'm going to subtract 40 from both sides of my equation. Okay, I'm left with h squared equals 49 minus 40 is 9. And my last step is to square root it. The square root of 9 is 3. My height is 3, or 3 feet. Okay. Example 2 I didn't love, so we're going to make some adjustments to it. Okay, there were some pieces missing. I'm going to first cross out some words, and I'm going to change some numbers. So cross out of the diagonal, cross out the next of the diagonal, and we're going to cross out the last of the diagonal. Okay, we're going to just kind of change how this is, and we're going to change this 15 to be a 10. Okay? All right, and now let's read our problem. The length across the front of the rectangular box is 20 inches. Okay, so the length across the front is 20. The length across the side is 10. The length of the diagonal is 23. What is the length across the top? So now front, side, and top are the same things as length, width, and height. Okay, so that's fine. We can call them any of those words as well. So we have across the front, or the length, okay, we have is 20 inches. Okay, across the side, or the width, is 10 inches. We changed it to be 10 inches. And then we also have the diagonal, which is 23 inches. We're looking for the top, or the other thing that we haven't found, a height. Okay, and that's what we're looking for. So fill in what you know. 23 squared is our diagonal, equals our length squared plus the width squared. And again, we can look for the height squared, or the top, or whatever across the top of the box is. That's fine. That's what we're looking for. So 23 squared is 529 equals 400 plus 100 plus h squared. Okay, so 500 plus h squared. I'm going to subtract 500 from both sides. So h squared equals 29. Final step, square root it. The square root of 29 is 5.38. The 8 tells the 3 to become a 4. So 5.4 inches is that height, or is that top of the box. And our last question, Pablo's packing for a business trip. He's almost finished packing when he realizes he forgot to pack his umbrella. Before he takes the time to repack his suitcase, he wants to know if the umbrella is going to fit. His suitcase is in the shape of a rectangular prism and has a length of 2 feet, a width of 1.5 feet, and a height of 0.75 hundredths or of a foot. Okay, 75 hundredths of a foot. The umbrella is 30 inches long. We want to know, is the umbrella going to fit in Pablo's suitcase? Okay, list what you know. Our length is 2 feet. Our width is 1.5 feet. And our height is 0.75 feet. Okay? The umbrella is 30 inches. Okay? So I'm going to have to make some measurement adjustments here because that's in inches and that's in feet. So let's go ahead and put everything, you can either put everything into feet or you can put everything into inches, okay? Let's do it by, let's leave it in feet and we'll change the inches at the end, okay? So d squared equals length squared plus width squared plus height squared, okay? So let's see. So let's find the length of the diagonal that the suitcase will have, and then we'll see if the umbrella is going to fit. So 2 squared plus 1.5 squared plus 0.75 squared. 4 plus 2.25, 0.5625. Okay. Add them together. D squared equals 6.8. And square root it. Okay, so then D equals 2.6 feet. The diagonal through his suitcase is 2.6 feet, so just over 2.5 there. But I don't know, I need to look in terms of inches to see is this going to fit. Well, I know there's 12 inches in a foot, so I'm going to multiply this number by 12 because that's inches in 1 foot. Okay. And then 2.6 times 12 is 31.2. Okay. Now, is his umbrella of 30 inches, is it going to fit in a diagonal of 31.2? Yes, barely, but it is going to fit. Okay, so the answer was yes. Okay. For your left-hand page, there are, let's see, 3 questions that you haven't finished, okay, that was given back to you. This is 4, 5, and 6. Those are 3-dimensional questions. So remember, with 3-dimensional questions, you need to make sure that you're using the formula. The code word for this lesson is Miss Earls. Okay, Miss Earls, as in the next door teacher, Miss Earls. Make sure you get your planner signed. If you have any questions, you can email me. Make sure that you turn that left-hand page in tomorrow. Oh, and this gets glued in. This gets glued in next to the foldable from the last lesson. All right, goodbye.